are going to take a test over all things polynomials and factoring. So I want to go over this foldable that covers everything we've done in this unit so you can make sure that you are ready to go for this test. So the very first thing that we discussed was collecting like terms and adding polynomials. And when we do like terms, we are looking at putting x's with x's, constants with constants. If we had more x squareds, we would put them with x squared. You cannot put an x with an x squared. They do not match. So we're just collecting like terms like you learned how to do in 6th grade, and you're only adding or subtracting those coefficients. You aren't doing anything with the variables and the exponents. So you can simply look at it. You can mark them. I've seen people mark them with different symbols so they know what to combine. I've seen people go ahead and write them out and then match, kind of like when you were in elementary school when you looked at things vertically, and you can collect like terms that way. So whichever way works best for you, as long as you can see here that my variables and my exponents stayed the same. I didn't do anything with those, okay? When you're subtracting a polynomial, though, you have to remember that this is a -1 that you have to distribute, which is why it says switch, switch. So you can turn this to a plus and change all of those signs inside, or, which is exactly what happens when you're multiplying by a -1. So we could say -6x squared minus 3x plus 1. And then again, whatever method you have, be it, marking them with the same symbol, or, oh, look, this one caught me off guard. Let me try that again. I apologize. I'm going to circle my x squareds. That was an x cubed. You got to pay super close attention, which I did not do. And then you can see here, this one would be by itself, and this one would be by itself. You can do it that way to collect like terms. Or again, I've seen people that want to line it up nice and neat. I'm going to put a 1 in front of this x right here, and then I can line them. But if you do not distribute first and change those signs, then it is not going to work out for you. So here we get 7x to the third plus 2x squared minus 4x plus 1. Again, notice that all I was changing were my coefficients, not my exponents, okay? So when you add and subtract, it's just collecting like terms like in 6th grade, nothing with the exponents. Now, when we go to multiply, we're using the distributive property. We're multiplying the coefficients, and now we are using our exponent rules. So we're going to distribute all the way through. If you want to put a 1 as your exponent on those x's, you can. 2 times 5 is 10. X times x squared is x to the third, because again, when I multiply, remember we have to add our exponents. 2 times a -2 is a -4. X to the first times x to the first is x squared. 2 times 9 is 18 with my x. Okay, so this, when you're multiplying, is when you end up changing your exponents. Adding and subtracting, we don't. So here is another one that is multiplying. Notice that this is different. There are no symbols in between here. So when there's a plus or a minus, like we had up here, right? We have a plus, we have a minus. That tells us we're adding and subtracting, and our variables and our exponents stay the same. But when there's no symbol, we're multiplying. You can do FOIL, or you can do box method here. Whichever method you prefer. 3 times 5 is 15. X times x is x squared. 3 times 7 is 21. X, right? First, outside, inside. A negative times a positive is a -20x. Negative times a positive is a -28. And now we're adding and subtracting. Now we're collecting our like terms. 15x squared, 21x, and a -20 is just a positive. You could put a 1 here if you really wanted to, but you don't have to. minus the 28. So you could do, so this right here, this is going to be FOIL, or you can do the box method, whichever you prefer. I'll do a box on this next one so you can see it. If you're doing box, make sure that you are in fact collecting those like terms. So again, it's entirely up to you. So I have a 2 by 3. Most of my class is kind of about half and half preferring. So 2x times x squared is 2x to the third. 2x times negative 7x is a negative 14x squared. Make sure you're still adding those exponents. 2 times 8 is 16x. 5 times x squared, 5x squared. 5 times negative 7, negative 35x. And then a positive 40. So you can see you do have some like terms here and here. So I don't have anything to collect my 2x to the third with, but a negative 14 and a positive 5 is going to be a negative 9x squared. Don't forget, some people are forgetting their sign in between, not necessarily when it's a negative, but when it's a positive. Negative 35x and a positive 16x is a negative 19x. Plus the 40. Okay? So you can do FOIL or box when you're multiplying. But when we are collecting like terms, we're adding and subtracting, we're just looking at those coefficients. Then we went on, we talked about factoring, and we talked about how factoring is the opposite of multiplying, or the distributive property. So we're really just looking at taking out that GCF. So really we are dividing all three of these terms by 8x squared. So I'm actually going to write it here and here so I can see what I'm doing. And remember, we learned when we're dividing, you divide your coefficients and you subtract those exponents. So 24 over 8 is 3. X to the 5th minus x squared is x to the 3rd. And negative 40 over 8 is a negative 5. X to the 3rd over x squared, so we're minusing is just x, or you can write x to the 1st, whichever you prefer. And then 16 over 8 is a positive 2. X squared over x squared is 0. Anything to the 0 power is 1. So now we are finished. So we needed to take that information, and then we can talk about greatest common factor. Now again, if you are not sure about what your greatest common factor is, numerically, you can use the calculator, but remember, a greatest common factor can be a number, it can be a variable, or it can be both. So make sure you're looking cautiously. If you're using the calculator, you can do menu to 5. So in parentheses, I would write 18, comma 21. You don't need to worry about that negative. The calculator is not going to do a GCF on your variables. So here, if you wanted to see that, not that you should need it on this particular question, but just as an example, so we can say menu, sorry, there's a really odd glare there, let me fix that, there we go, menu to 5, 18, comma 21, my GCF is 3, but hopefully you knew that. So we can say if we're taking out a 3, but then I have my variables match. They're both x's. And remember, when the variables match, you're going to take out the smallest degree. So we're going to take out an x squared. That GCF always, always, always goes outside of your parentheses. Then you can divide like we did up here. So 3 goes into 8. 6 times x to the 5th minus x squared is x to the 3rd. 3 goes into negative 21, negative 7 times. Oh, I'm sorry, I did way more work here. They just asked for the GCF here. I went ahead and factored it. Sorry, 3x squared. I got ahead of it myself. This is the GCF, and then I actually did factoring, which is the example down here. So let's try that again. Sorry about that. The GCF here is going to be, should be 5. And they both have an x, and the lowest degree is just 1. So we are going to have to divide both of these by 5x. 5x is going to go outside, and now we are dividing. So we're going to say 5 goes into 36 times. X squared over x is x. 5 goes into 35 7 times. X over x is just 0. 0, x to 0 is 1. So the way to check this is if you were to go ahead and distribute, like we did up here on example 3, you should end up back with 30x squared plus 35x. Here we can take this one. There is no GCF numerically. Okay. There is also no GCF with our variables, but we can use our cross puzzle. We don't have a b value. Essentially, this is saying minus 0x. That's our b. So a times c, this is a very large number. 9 times 49 is going to be 441, and I have 0. This is a negative, so we have the same. I will tell you that 21 times 21 is 441. Sorry, this should have been a negative. Okay. This is a special trinomial like we learned about yesterday. So the shortcut is take the square root of both of them. Square root of 9x squared is 3x, and the square root of 49 is 7. Because this is a negative, you're going to have a positive and a negative. If you're going to do your cross puzzle over here, then you're going to have to simplify this. And if you are unsure about simplifying, you can put those fractions in your calculator. It will simplify it for you. So we have 7 over 3 and 7 over 3. Remember, you're going to swing that denominator forward, and you can see right here, 3x plus 7, 3x minus 7. So if there's not a GCF that comes out, try your cross puzzle. Okay? When we look at, that's when we have 2 terms. So when we have 3 terms, then you can make your table. We're not actually going to make a table. We're going to make a cross puzzle. Make that X puzzle. So where we have A times C and we have B, we have a negative 24 for AC. B is 2. If A times C is negative, these signs are different. List your factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And because these signs are different, we have to figure out which of these subtract to give me 2. Well, 6 minus 4 is 2. Now you have to think about, if I want a positive 2, is it a positive 4 and a negative 6, or is it a positive 6 and a negative 4? Well, if I want a positive 2, it needs to be a positive 6 and a negative 4. My A is 1. I could technically swing my 1 forward, but that's not really necessary. So my factors are x plus 6 times x minus 4. Now you can do a couple of things here to check your work. You can FOIL, or you can box, or you can go to your calculator and you can make a graph. Okay? If you make a graph, you can put in this and this. If they overlap, you're good to go. So let me show you what that looks like. X squared plus 2x minus 24. There is my parabola. Very pretty. If I hit tab, I can put in a second one. Now you need to use your parentheses. X plus 6, close parentheses, parentheses, x minus 4. If we did it correctly, look how it overlaps. Red and blue makes purple. We checked our work. We did a good job. So that is a little trick you can also do. On number 11, you can do your cross puzzle. You can also notice that these two are perfect squares. You could use your shortcut. I'll show you both methods. 100 and b is negative 20. So if this is positive but this is negative, they're both negative. What times what is 100? That gives you 20 would be 10. So we can say, in fact, that this is x minus 10. You can say times x minus 10, or you might see it x minus 10, the whole thing squared. If you're going to use that shortcut that we learned yesterday, you take the square root of the first term and the square root of the last term. Square root of x squared is x. Square root of 100 is 10. So is this middle term, remember, 2 times the square root of the first term times the square root of the last term? Yeah, that's 20x. That worked. So then you can see x sine of b, 10. What do we do when a is greater than 1? Again, this is going to be the swing method. Okay? So we're going to look at that swing method and see what happens. There is no GCF here. Always double check that. There's no GCF. We can go straight to our cross puzzle. 2a times c, so 2 times a negative 15 is a negative 30. B is a negative 7. If this is negative, that means my signs are different. And I'm going to have to subtract to get 7. So my factors of 31 and 30, 2 and 15, 3 and 10, 5 and 6. So what subtracts to give me 7, 3 and 10? Now, again, think about your signs. What needs to be negative for this to be a negative 7? Well, the larger. So a negative 10 and a positive 3. Now, a is not 1. So I can come over here and I can say x plus 3 times x minus 10. But I'm not done. I have to divide that by 2. This does not simplify. I'm going to swing my 2 forward. I get 2x plus 3. This does simplify to 5 over 1. I'm not really going to swing my 1 forward. I technically am, but I'm not going to write it. So x minus 5. And again, you can go through to your calculator and you can graph these. You can say tab, and we can put in 2x squared minus 7x minus 15. And then you can say tab, parentheses, 2x plus 3, close parentheses, parentheses, x minus 5, close parentheses. If we did it right, they overlap. Oh, very pretty. Red and blue makes purple. Here is another example. Again, this is going to be a special case because 9 is a perfect square and 25 is a perfect square. There is no GCF here. You could do a cross puzzle. It's going to be really large because 9 times 25 is 225, I believe, positive. So if you want to list all your factors of 225, 3 goes into 225, 75, 4 doesn't, 5 does, 5 goes in 45 times, 6 does not, 7 doesn't, 8 doesn't, 9 does, 9 goes in 20, 18, 45, 25 times, 10 does not, 11 doesn't, 12 doesn't. I think we have to go all the way to 15 before we get the next one. We get 15 and 15 because, again, perfect square trinomial. So they're both positive, so we're going to have to add them. So we can say x plus 15 times x plus 15. A is 9. Don't forget that. If I put in my calculator 15 over 9, it simplifies to 5 over 3 because we have to make sure we simplify. So I can write 3x plus 5 times 3x plus 5, or you will see 3x plus 5, the whole thing squared. If you do your shortcut, the square root of 9 is 3, the square root of x squared is x, the square root of 25 is 5. 2 times 3x times 5 is, in fact, this is 6 times 5 is 30. So you could have also done the shortcut, 3x sine of b, and then 5. So if you are comfortable with the shortcuts, go ahead and use that strategy. You could, of course, graph it to check your work. Last page, and then hopefully you'll be feeling pretty good for your test. Factor by grouping. We did this way at the beginning. There is no GCF between all 4 of these, but I can group my first 2 and my last 2. And I have a GCF here of 2x squared. So when I take out 2x squared, I get 3x minus 7. I can take out a GCF of 9 here. 9 goes into 27. I'm going to put my 9 outside. 3x minus 7. And remember, when you do grouping, you want to make sure that you end up with that same term. So now my GCF is the whole expression 3x minus 7. So now it's going outside. And I am left with 2x squared plus 9. Okay. So hopefully you feel pretty comfortable with that. If not, you can always go back and look at your notes because that was kind of a while ago. So in your overview, if you have 2 terms, is it a difference of 2 squares? Always make sure you can take that GCF out first. 3 terms, always. First step in all of these, no matter how many terms, is there a GCF? Perfect square trinomial, or you can do the cross puzzle, A, C, and B. Don't forget to swing if there is an A. If there's 4 terms, you can factor by grouping. Good luck on your test. Please make sure you ask any questions that you might have. Don't be afraid to use your calculator to check your work.